How are you doing today? We are in chapter 4 of volume 3, and we're going to talk about instrumentation and control. When you work at a water or wastewater, it is imperative that you have instrumentation. The instrumentation talks to the SCADA system. You have instrumentation and control in your laboratory. And so I just briefly want to go through this chapter with you and highlight some things about instrumentation. On page 199, the first thing I want to highlight is a field device. So a field device is a sensor or other instrument that produces an electrical signal in response to a physical condition, such as temperature, flow, velocity, or pH. So that field device will then talk to our SCADA system. That SCADA system then can be record or then alarm uh, the operator to maybe a high level alarm, um, perhaps a pH swing in the system can alarm the operator so that he can come in and fix it. So we have to have a field device out in the field. When we talk about these devices on page 200, field devices are also uh, capable of transmitting digital output signals to a PLC. And then that PLC will talk, and if you don't know what a PLC is a programmable logic controller. Um, you can start equipment, verify equipment's running, and you can have pressures. So our plant uh, is driven by the iPhone, so I can go on at my house, log in, hit a button, and start and stop a a pump that's out in the distribution system. So the iPhone talks to the computer. The computer then talks to the individual PLC and then sends it out the start stop or some other command that I give it. So instrumentation is important to what we have. When I talk about PLCs, on page 202, a PLC is a microprocessor based electronic device that automatically executes and processes control commands based on the analog and digital input. So, um, on page 203 is a PLC rack, and you'll have these in your plant. These are usually not in the admin building, but they could be. Um, so that computer is sending signals to the input and output of those racks, and those racks are then sending either a control voltage or a normally closed or normally open switch, which would then turn on a pump or turn on a blower, or maybe if you have a actuating valve, it may turn the valve down or out. So when we talk about PLC racks, that's what we're talking about on page 203. And that's just a series of inputs and outputs. So you have the inputs from the computer, maybe preset standards that you have, and then you have your output. So your output would then control um, or turn on a piece of equipment. So SCADA, when we talk about SCADA, it is a supervisor control and data acquisition system. A facility SCADA system communicates with all PLCs at the facility and allows the operators to view and modify. So at a facility, you could have several PLC units or PLC racks or um, controllers that didn't talk to an individual rack or talk to a series that can be relayed over a network or a radio transmission unit back to your back to your SCADA system. A lot of times on page 207, we do have the opportunity to run those in manual, but with the SCADA can also have the ability to turn on or send a signal to a VFD. And we've talked about VFDs and how important that is to our system so that a pump is not just turning on, turning off. On page 208, there is what picture of a pumping station looks like. That's your standard. You have your pump one, pump one seal fail. That's if water gets into it. Pump two, if or pump one or pump two overfault. So it kind of has your alarm. You can see that there's a selector switch. When we run that in auto, we're usually allowing it to be controlled by an external source, whether that be floats or the SCADA system um, that we have. When we talk about wastewater lift stations on page 209, sometimes those are controlled by floats. Sometimes they're controlled by ultrasonic measuring devices. But normally, how they're set up is you have a low level alarm. This is if the pump fails to stop and it pumps the water too low. Then you'll have your next float or control point, and that'll be pump all stops. So this de-energizes any pump that is kicked on to its stopping point. Then you'll have your lead pump start, your lag pump start, and then obviously you will have either a high level alarm or high level float. And typically all your lift stations are uh, operated in this manner or set up in that type of manner, either with switches or some other level sensing device. 210 has a good picture of that float system that I'm talking about. Uh, 211 is an HMI screen. So throughout the plant, you may have an HMI screen at each individual stage or building of the process. This just allows operators to have um, continual monitoring and access to it so that you don't have to go all the way to the admin building to make process changes. On 211, you have an open loop controller. Uh, that's where you have the flow meter sending a signal to the controller. The controller then either speeds up or slows down the chemical pump. Um, on 212, obviously you have a uh, a closed loop system. So when it's sending that chlorine residual measurement back, then that controller is either turning up or moving down the chemical going into uh, the system. Safety hazards, we've talked about this several times, but we want to make sure that we are using lockout tagout anytime we're working on a piece of equipment, especially if that's controlled by SCADA. Someone on the other end could see a pump being down and can just turn that on to auto. So it's imperative that we lock out our equipment. On page 219 is another confined space check off list. When we go in um, to areas for confined space, some of those are permitted and some of those are non-permitted. A permitted required confined space has one or more of the following characteristics on 218. Contains or has a potential to contain a hazardous atmosphere, contains a material having potential to engulf an entrant, having an internal configuration where the entrant could be trapped or asphyxiated by inward converging wall or sloping floor, contains any other recognized serious safety or health hazard. Just for me, When you work in wastewater long enough, you can start to tell when you're in a confined space because it's not made for human occupation, and there's a potential usually for lack of oxygen or possibly explosion, gases, those types of things. So when we do confined space, when in doubt, treat it as a confined space. So VFDs, we've talked about VFDs. There's a Power Flex on page 221. But VFDs adjust the voltage and frequency of all utility power. Um, they're more energy efficient and they improve the process control. So a VFD will, as water comes into a lift station, instead of that pump just kicking on full blast, that VFD will see the level through a field sensor that talks back to a SCADA, and then that SCADA will send a signal to the VFD, and that will control the pump. It will turn it up and turn it down so that we can just pump a nice, steady uh, series instead of wearing out the pump with a bunch of starts and stops. VFDs, they are nice when they work. Um, just kind of known on 223, you have a rectifier, you got AC to DC. The DC is stored and then it converts it back to DC to AC. I've had a lot of problems with the DC link going bad. VFDs are nice, but you have to make sure they're clean. Make sure they're in a building that doesn't get dust, and if it does, you need to clean them. Um, but they've kind of become throwaways. When I first started, VFDs were super expensive, but now they have come down in cost, and sometimes it's just easier to buy a new VFD than to send one out to repair, especially with all the electronic components that go along with it. We used VFDs in water and wastewater. So let's talk about sensors. Flow metering on page 234. We use a lot of different ways to measure the flow coming into a plant or inside the plant. So, we talked about the open channel flow system uh, as a partial flume. Partial flume is usually in your influent and your effluent. It's one of the most common. It was developed by Dr. Partial in the 20th century to measure the surface water for the agricultural industry. And you can see on page 241 is you have the flow, you have the converging section, the throat, and the diversion section. And the level of the liquid passing through the throat section is proportional to the velocity, which can be used to estimate the volumetric flow rate. In most cases, the liquid level in the flow is measured by an ultrasonic level measurement because the device does not come in contact and will not introduce obstructions. So there's an ultrasonic um, sensor there at the throat, and we're using this uh, to measure the flow and the amount of water coming through. This is a good on page 240 is a good pictorial of each flow meter. You have a Marshall flume, the level, the Doppler, the transit, the turbine, the paddle wheel, and the electromagnetic, and which part that you're going to use it in. So obviously a partial flume, we're going to use it more in a open channel. A paddle wheel, obviously we're going to use it into an enclosed pipe. Um, and so this is a good pictorial of those. So electromagnetic meters, they're common in the wastewater systems. They're typically flange mounted, so they're integrated with piping systems. These instruments generate a magnetic field that the flow passes through as it travels down the pipe. The principle of the operation is based on Faraday's law of electromagnetic induction, which states that voltage is generated when the conductor moves through the magnetic field. One reason why we like magnetic meters is because there's no internal parts for sewage to get caught on. Um, and it is one way that we can measure without having the maintenance of like a paddle meter where we have to continually remove rags and debris from that. When we're talking about meters, all meters, even the partial flume, all that needs to be calibrated once per year, typically, or according to your EPA regulations. Ultrasonic meters. Ultrasonic meters function by emitting high frequency sound waves that are reflected by the liquid in the flow path to determine velocity. So you can have ultrasonic meters. Um, transit meters are similar to Doppler meters in appearance, ease of installation, portability, and pipe material compatibility. While both meters have transmitters and use ultrasonic waves, they differ in operating principles. While the Doppler meter measures the frequency shift of the ultrasonic mission, transit meters determine the velocity by measuring the amount of time needed for the ultrasonic pulse to travel a known distance in the pipeline. Um, there is on page 250, there's a partial flume using an ultrasonic device for measuring liquid. Ultrasonic level sensors provide a wide range of analog and digital outputs. Let's talk about mechanical flow meters. The most common type of mechanical flow meters are the paddle wheel and the turbine. On page um, 253, you can see the insertion type paddle wheel or the turbine mechanical flow meter. We do use pressure sensors in the wastewater system to measure the pressure in tanks and in other areas. It's important to know that we use 0.433 psi per foot head. That is a test question that we often get on our wastewater test. Temperature. So temperature is an important variable in a wastewater system. Some plants require you to measure the temperature continuously. So you need to look at your permit. Um, you know, on page 266, you can see a thermal imaging. What he's doing there is he's shooting the motor and to see how hot the bearings are. So if the bearings are going bad, the obviously the more heat that will emit. And so keeping a good record of the temperatures of your bearings are important. You can see on page 275, there's a operator inspecting electrical service with a thermal imaging camera. He's looking for hot spots. Um, you can see he's in that weird outfit. No, he's not collecting bees. That is a special protective wear, arc flash wear to protect him from arc flash. pH measurement. One of the most critical variables measured at the wastewater plant is pH. So you may have um, a pH meter that is a field device, or you may have one that is at your wastewater plant. And so knowing how a pH um, works is important. So a pH electrode on 280 is a potential electrochemical cell consisting of a reference electrode and a glass ion selective electrode, impermeable to hydrogen ions. When electrodes are submerged in an aqueous solution, a circuit is formed and generates an electric potential proportional to H. The reference electrode and the ISE are connected to the meter and to other device and calculates the pH based on the voltage potential in millivolts and the temperature of the solution. So you can kind of see how a pH meter works on page 281, and it's that millivolt potential that they are measuring. Here's another good picture on 283 of a pH meter and how it is using that millivolt reading, and we get that when we calibrate. So when we calibrate, usually we'll calibrate with a 7 and a 10, and then check with a 4, depending on what type of system that you are working on. But typically we calibrate once per shift or every day. And it's always important as operators uh, to to have extra um, probes because those can get fouled through fats, oils, and greases, which get on the probes. On 287, you can kind of see a portable pH meter that we can use. Maybe you will have um, a a mounted one in your laboratory, but that's a portable one. Conductivity. So when we talk about conductivity is the measurement of how well a substance such as water conveys electrical current. The most common conductor used to power electrical devices is copper wire. So when we talk about conductivity, we're talking about the degree of aqueous conductivity and heavily influenced by the charge density and the concentration of ions. Um, why we measure this? It's a good indication of our TDS that's in the water. It's not pound for pound, but when we talk about it, you can see on page 293, pure water, deionized water, is low conductivity, meaning when we are measuring it, there's not a lot of substance in there, any kind of minerals or hardness to give us a high reading. So obviously, salt water, you're going to have more of that